scientist, I want to show you how you can develop a model to predict formulas for ionic compounds. And one thing I like to do is have some steps that I can take to make the work easier. And so these are the steps that I take, and I hope that you can find them useful for you. Step 1 is I jot the symbols that I need for each of the elements, and then I determine their charges. Next, I draw their respective Lewis dot diagrams, and then I'll calculate the number of elements needed. For this example, I found out that I needed 2 chlorines instead of just 1 in order to have a stable ionic compound. And then last but not least, use some arrows to represent the transfer of those electrons. Now, you don't have to worry about this part right here yet. That comes later. All you need to worry about today is learning to do this part and then how to write the formula. And I'm right here to help you. Okay, so one thing I like to do for my practice work is my sticky notes. And so for this one, I'm going to be showing you potassium and oxygen. And then for the next one, I am showing you aluminum with oxygen. Okay, one handy tool you need in front of you is, you guessed it, your periodic table of elements. Okay, so what I did go ahead and do, and you should do this on your sheets, is make sure you have the charges across the top of each column. Your brain will thank you, I promise. Okay, so first let's figure out about calcium. Calcium is over here in the first group, and that means it has a +1 charge. So let's do that right now. Okay, now what about oxygen? Oxygen is way over here in group 16, and it has a -2 charge. Okay, now my next step is to figure out the Lewis dot diagram. Okay, so I'm going to use red for the metal, which is potassium, because it's over here on this side. It's over here. These are the metals over here. Okay, so potassium is in group 1. That group 1 tells me that it has only 1 valence electron. So I'm going to represent that with a dot at the top, kind of off-center to the left. Now, oxygen, on the other hand, is way over here. It's a non-metal because it's over here in this little part. Now, it's in group 16. There's 2 ways you can do this. You can take that number 16, take away 10, and get 6. That means you have 6 valence electrons. The other thing is use the Roman numerals. In this case, the V followed by the little L beside it, that's 6 also. So this is going to have, oxygen will have 6 valence electrons. So let me switch colors, and let's do that. Okay, so there's a way we got to do this. We got to go counterclockwise. So we have 1, 2, 3, 4, 5, 6. All right, notice that pattern. Okay, now, one thing you're going to notice is that we have an empty space for an electron to go here, and another electron can go right there. So we can take 2 electrons for oxygen. So, but we only have 1 potassium, which has 1 valence electron. What do? We give it another potassium. Okay, so now what you will do is draw the arrows. So I'm going to take this one way over here, and this one way just right here. Okay, and now you're that far. So your next step now is going to write out the formula. You always want to write your metal first. Metal goes first. Metal goes first. Okay? So I notice I have 2 potassiums. So I'll do my K. I got my 1+ charge. And now I have my 2, because I have 2 of these babies. Okay? Now we got oxygen. We only have 1 oxygen. Ta-da! And you're done with this. Okay, so